last class we were saying what are different types and what are value types. And I know we are familiar that value types are the variables that are stored in the stack, whereas the reference type are the type of variables which are stored in the tool. Now sometimes it will be required for you to interchange the values from the stack to the heap, or to get the value from the heap back to the stack. In that case, we go for boxing and unboxing. This concept is the same concept that you have studied in the Java programming language. So let's look at what is boxing. So boxing is a process of converting a value type to a object type. Now by object, I mean to say that system.object, which is the base class for any data type that you are deriving. So let's look at a simple example, which is over here. If you say that int I is equal to 1, 2, 3, it just means to say that on this stack, the 1, 2, 3 is being stored with the variable I. Now, how do I place this I into the heap? The way in which you do it is you create a object which is nothing but a system.object. You create a variable of type object and then assign that I to this object. In that case, what is it going to do? In that case, because it is of type object, it's going to create a reference in the stack. And it's going to point to a object. Which is that object? The object that it is going to point to is a wrapped integer. So what is it going to do is it's going to take the integer, wrap it as an object inside an object, and it's going to place that object in the heap. And this is what is the boxing. What is unboxing? Unboxing is the reverse of boxing. That means to say that if you have boxed a object into the heap, you can retrieve it back by using the unboxing. So let's take the same example over here. So I have this I is equal to 1, 2, 3, and I box it to the heap. Now if I want to get it back to the stack, then I can say object O, which was boxed here, and I typecast it as int. In this case, what it is going to do now is it's going to retrieve this object from the heap, and it's going to take the value of integer and then place it as a value type in the stack. So this is unboxing. So you can box it and then you can unbox it. However, there are few things that you must understand. One is if you try to unbox a object that is null, unbox a reference which is null, that means it's not pointing to anything, you get a null reference exception. And if you try to unbox a mismatched data type, that is incompatible data type, in that case you get a invalid cast exception. That means to say that if you have, instead of integer, if you have casted or if you have boxed a float, and then if you want to get the float back to an integer, that means what was boxed onto the heap was float, and now you want to retrieve it as a integer, that's not allowed. So for example, if you, in the same example over here, if you try to box, say if you, instead of this, if you try to say boolean k is equal to boolean of O, which was the casted object. So this O is the integer over here, and if you try to cast it like a boolean, you will get a exception here. And the reason behind it is it's not possible for it to cast the boolean or integer as a boolean value. So you get a invalid cast exception. Let's look at arrays. So what are these arrays? And we are familiar. Array is nothing but a sequence of similar data type elements grouped together, which are indexed. Let's look at few of the properties of the arrays. These properties are same for any programming language, so it's not a different thing. Elements, every element of the array will contain some value. So either it could be a pointer or it could be a value itself like integer or some other data type. Arrays are zero index, that means to say that their base is zero index. So you start with the index 0, then go on. Length of the array, which is the general definition, that says the total number of elements within the array. The next one is the lower bound of the array is the first element, and the arrays could be single dimension, multi-dimension, or jagged array, like that of Java programming language. Depending upon the number of dimension, you can say that the array is one dimension, two dimension, or array has rank 1, rank 2, and rank 3. So rank refers to the number of dimensions that you have. Suppose if you have an array for matrix that is the row and column, then you say it has a rank 2. So how do I declare a array in C#? First thing is whenever you declare an array, you are actually creating an object of type system.array. So these are nothing but all arrays are derived from the system.array. So that means to say that there are some built-in properties that are exclusive for the array. So how do I declare an array? To declare an array, you specify the type of the array, put the square bracket and specify the name of the array followed by the colon. For example, if you want to create a single dimension array, you just create a type int. You say the data type is int, then put the square bracket, then followed by the name of it. If it is a two-dimensional, you put a comma in between and then two-dimensional. If it is a jagged array, then put the two square brackets separately. Now, once you create an array, you can initialize an array by giving it a specific dimension. The way in which you do it is, suppose if you have declared a single, then you can say new int of 20. That means to say that it's going to allocate 20 locations of type integer, and it's going to give a name as single bin, which can be used to point to all those 20 locations. For a two-dimensional array, you are going to say that the number of rows and columns as the dimension. Again, there is two other ways in which you can create the two dimension. We are going to say it slightly later. One of the way is you just say is equal to new int and then specify the value. So what is it going to do is it's going to create a 2x3 array, and it's going to fill the array with this value. So 1, 2, 3 will be in the first row, 4, 5, 6 will be in the second. Directly it is going to create it. Jagged array, you are already familiar, are the type of arrays whose dimensions vary. So you can have the second dimension, variable second dimension, and that's called as the jagged array. Now when you try to create a jagged array, you must declare the dimension of the first array. That is required if at all you are doing it. Without this, the declaration will not work. So here what is being said is there will be one dimension, and the second dimension is one more array. It is, if you are not familiar, these are the arrays of array. So let's look at a single dimension array. In order to create a single dimension array, you specify the type of the array, put the square bracket, name of the array equal to new, then type and specify the size. For example, I have the int ARR, which is of size 100. In the same way, I can also create the two-dimensional array. The way in which I create a two-dimensional array is I specify this is an example for int a equal to integer 3, or you can declare it this way. The shortcut for this is they have given a very simple shortcut. Suppose if you want to create an array and then store 3, 4, 5 directly into that array, that is the array of size 3, you can just say that int array of say and then give the default value for them. So it's a simplest way of creating the array. Arrays are not restricted only to the value types. They can be used to create an array of classes or interfaces, structure, or anything for that matter. So here, assuming that some class is a class, you just create an array of classes, array of structures, and so on. Let's look at a two-dimensional array. two-dimensional array, you have to specify the size of the row and the size of the column. For example, 2, 3 will create a square array. This is going to be a rectangular array. Then the other way of creating it is you create a new and then specify the dimension and specify the first values for the first dimension, values for the second dimension. You will notice that these values are separately placed within the brackets over here, and there is a separation at this point. That to say that these are the first one is the first row, the second one is the second row. Both of them together are placed within the array. So this first row and second row are together placed in a square array. The easiest way to create a square array is you just specify the dimension for the number of elements in the first dimension, number of elements in the second dimension, together, place them together in the square array, and it's going to work. Let's look at a jagged array. Now, I have already told you jagged array is an array of array whose dimension is irregular. So, if you notice over here, the second dimensions are not square. You have 4 elements, you have 5 elements, you have 3 elements, you have 9 elements. So, this is an array of arrays. So, you have created it in your C program by using the pointers, array of pointers that point to some other element. This in Java also you have created that thing. So, these are called as jagged array. Let's look at how to declare a jagged array. So, in order to declare a jagged array, you have to have 2 separate square brackets. So, look at the difference between this and the previous declaration. In the previous declaration, the comma was there within the square bracket. So, this is going to create a rectangular array. Whereas, if you have this separate square bracket, it is the jagged array. That means to say that it's an array of array. So, there is one array followed by the other array. And one important thing, whenever you try to declare it, you have to have the first dimension being declared. So, it's defined how many elements will be there in the first array. In the second array, you can declare it separately. So, here it indicates that there will be 2 elements. So, you have the 0 and you have 1. So, this will be the 0th index and 1 index, and that is what is the meaning of saying there will be 2 elements in the first dimension. That means to say that you are going to restrict yourself to an array of this type with the 2 elements. So, these are the 2 elements that are being referred there. So, let's look at the way in which you declare it. Once you declare the first dimension, then you can specify the second dimension. Once you specify that there will be 2 elements, then you will have to say the first one will be pointing to an array of size something. The second one will be pointing to an array of size something. The way in which you do it is the first one will be pointing to an array. The second one will be pointing to an array. So, the size of it can be varied. So, it could be 4, it could be 6, it could be 5, it could be anything. So, here you say that this is the first dimension. First dimension is pointing to an array of size something. Second one will be pointing to an array of size something else. You can also directly declare an array with the elements. The way in which you do it is you say new int, then you say 1 row, that is the element in the first dimension, which is a 1-dimension element in the second dimension, which is the second dimension, and you notice that there is a comma. So, from here to here will be the element in the first row, and from the second one will be one more array that will be pointing to the second element. So, let's look at one more example wherein we have element 2 elements. So, I have a of 0 equal to new 3. So, a will be pointing to 3 element array. A of 1 will be pointing to a 4 element array. If you compare it with the other type of array, that is a rectangular array, you are not going to specify the 2 square brackets here. You are going to specify it as a single bracket, and when you specify the size of the array, you will have to specify the size for both the first dimension and the second dimension. Whereas in the case of the jagged array, you are supposed to specify the dimension of the first or the size of the first dimension, not the second one. How do I access the element? How do I access this element? The way in which I do it is X, the first array you're pointing to, and within the first array you're pointing to the second element. So this is how you do it. How do I do it in a squared array? It is simple. First row and column, so it's going to point to that element. Now, how do I find the length of the array? Now, whenever you have created the rectangular array, the length of the array is a dot length, which is the same method or the same property that even the Java has. A dot length will give you the length of the array. When it is a rectangular array, the length will be multiplication of these two values, that is 2 into 3, which is going to be 6. That will be the total number of elements which are stored within the array. Whereas when you talk about the jagged array, if you say a dot length, it's going to give you the length of the first dimension that you have specified. It knows only this length, so it's going to give you this length, that is the size is 2. How do I get the dimension of the second dimension, or the size of the second dimension? In that case, you go to the first array here and then say that first array is pointing to one more array and I want to get the length of it. The way in which you do it is you say a of 0, that will point to the first array of the first dimension, first array, and then you get the length of it. Similarly, you can do it for the other. But such a concept is not there in a rectangular array. In that case, what you are going to do is, if you want to get the dimension of the first and the second, you just use the built-in function called as get length of the rank 0, that is the dimension 0 and the dimension 1. So that is the first dimension, it's going to give you 2. The second one is going to give you the 3 values. So 2 and 3. It's going to give you that value. Now let's look at some of the functions which are built into, or some of the properties which are built into the array. So array has the length, which will give you the count of elements within the array, which you are already familiar. The rank of the array will give you the dimension of the array. It just says it has only one dimension, so the rank will be 1. You can also use the copy to function to copy from one array to the other element or other array. So what is being done over here is you create 2 arrays over here. So the first array, so assume that you have 2 arrays over here and you want to copy from one side to the other side. So you are going to say copy to, you go to the first array and you are going to say that copy to the second array. So copy from the old numbers to the new number, and you are going to say from where you are trying to copy. So this is from where. I want to start from the 0th index. You can say that from here I want to copy to this location. So I want to start copying to the 5th location. You can say that, and then you can say that only 5 elements or maybe only 3 elements need to be copied. So you have more options over here that is not shown there. So you can say from where you want to copy, how many elements you want to copy, and where you want to put on the other side. So all these options are available. So you can say that copy from the 3rd element, from the 3rd next 5 elements, copy to the 8th location on the other side. So you can say that. So starting location, number of elements to be copied, and the starting location at the destination. So it is not just making a copy of one array directly to the other array. It is, you take an array, you can say that I don't want all the elements within the array. I want to copy only few elements from the first element, first array to a specific location in the second array. It is possible. Again, like the Java, you have the array sort, that is used to sort the array in the ascending order. This will be a helpful thing when you try to sort. So how do I access the element of the array? To access the element of the array, the general technique you are already familiar. If this is an array of one dimension, you specify I want to access the 3rd element. This is the index 0, index 1, index 2. So this is going to give you the index. Index is always one less than the value there. So it's not the second element, it will be the third element. The other way of doing it is you just use the built-in method called as get value. It's going to retrieve the value and give it to you. Using the for loop, which is the generally used way of doing it, is for int I is equal to 0 to the length of it, you retrieve it, or there is a built-in function called as built-in for loop called as for each that will iterate through all the elements within the array or within the collection for that matter, which will be much easier if you try to do it. So, for example, you have an array, you are the one. This is an array of string. I want to print all the values one after the other. So, I'm going to say for each string, yes, in this array. So, what I'm saying now is this string has to point to all the elements within the array. So, this is the meaning of it. For each string in the array of string, get the value. So, when the for loop iterates, every step is going to take one string and it's going to retrieve it to you. The same way, if you have an integer array for this one, you can say for each int, because it's an integer array, int I within the array, give me all the elements. Once you get the element, you can do anything. Remember, what you get is not the element. When you say for each string in it, yes will be pointing to one element over here. You are not going to write a array of I, array of j or anything. Here int will be pointing to these elements. For every for loop, it's going to point to one element. So I itself will be the value that you are going to get. You're not going to write int array of I or array of j or array of s or anything of that kind. You just use the value I. Okay, this is a two-dimensional array, example for two-dimensional array. So we have a data which is 3, 5, assume that it is filled. So how am I going to do that thing? So I want the dimension of the first. I really don't know what is the dimension. So I'm going to say for int I is equal to 0, data dot length of get length of the first dimension. I print the row number and then I go to the second dimension and say I want the dimension of the second. So if you don't know the length of the array, you can also use the get length function to get the dimension of the first or the second or third or nth dimension. Okay. Let's look at the string operation. Like the Java, strings are immutable. That means to say that whenever you concatenate two strings, you are not going to add the string to the existing string. What you end up in is getting a new string altogether. So when you say address is equal to 2, what is going to happen is there will be a pointer address which will be pointing to a object in the heap and it will have the value 2. When you say address is equal to address plus Sharada Nagar, what is it going to do is it's going to discard this whole thing. Instead, it's going to create a new object altogether and that will have 2 maybe space Sharada Nagar. So, and you will be pointing to this one. So that means it's going to create a new object altogether. It will not be doing anything with the previously available object. In the same way, when you try to do this one, that is address plus DD, what is it going to do now is it's going to create one more object altogether and it's going to discard this object. We'll recreate one more object with the 2 with Sharada Nagar and with DD. So that means to say that whenever you manipulate a string, the existing string is not modified. It actually creates a new string and then uses it. Now this is not a good idea because whenever you try to concatenate, you are losing a lot of memory and you want to go for a new allocation. Now if you don't want to do that, if you want to concatenate within the same allocation, then you have a function called as string builder. A class called as a string builder. String builder will allow you to manipulate the existing object itself. So, but it will not behave like a string. Whenever you want to concatenate or whenever you want to do something with the string, do it in a string builder, and then ask the string builder to convert the final output into a string. So let's look at how it is being done. So we create a object of type string builder, and then we say append to this, append Sharadanagar to it, append Biri to this. Now all these append that you are going to perform will be done on the same object. This will be the same object on which all the operations are done. So we are not going to create new object for every manipulation, but once it is done, you can't use it like a string. Once you have built your string, then you call toString method on this string builder to convert it into a string. So finally, once your manipulations are over, convert it back to a string. So this will help. The advantage over here is it will reduce the overhead of getting an allocation in the heap, and also it will prevent in the memory loss and unnecessary garbage collection being fired whenever you use the string. Let's go to the next matter, that is the classes. You are already familiar in like Java. We have classes over here. Classes is nothing but a blueprint for creating the object. The classes in C# also have a single inheritance. That means you can have a class that has two parents. So this is not the same type of class that you have it in C++, wherein a class can inherit from multiple parents. It is not allowed in Java as well as in C#. However, like Java, C# also allows multiple implementation of interfaces. So you can have a class that is implementing more than one interface. It's always allowed. Then let's look at what is there within the class. Class can have fields, constant, method, properties, indexes, event, operators, and so on and so forth. You are already familiar with it. So a class can also have static members, as well as you can have a nested tags within the class. Like the other programming language, the members in the class can be hidden by specifying the specific access specifiers, and we have different types of access specifiers. They include the public, protected, inherited, internal, private, and internal protected. I'll come back to that type in the next one. So what is a field? Field is nothing but it's a member that is used to store the state of the object. And what are properties? Properties behave like fields, but they have the getters and setters associated with it. So in Java, we exclusively specify getters and setters, whereas in the C# or like VB, you can create a properties which behave, which looks like a field, wherein you directly assign the values and retry the values, but in turn they have a method called as getter and setter, which are called as accessors, which are usually not shown. In Java, accessors has to be shown like a method, whereas when it comes to the properties in C#, you can use them like a field. The next one is the method. You are already familiar. Method is used to take some action. So when you call a method, you assume that something is going to happen. The last one is the event. Event is when you want the class to respond to something that has happened elsewhere. That is what is the event. So an exception, some values have been set or something. In that case, you want to handle it. You have the event. So let's look at the access specifiers. There are altogether 5 access specifiers. One is the public. Public means if you create something as a public, it will be available everywhere, not only in this class, outside this class and outside the assembly. Remember, our boundary for doing anything is an assembly, so they will be visible outside the assembly. If you say private, that means to say that the members or the fields which are declared as a private will not be available to the outside world. It is a private to the class itself. What is internal? Internal means to say that this will be available to all the classes within the same assembly. So suppose if you create a assembly, now I've already told you within the assembly you can have many classes. Now if you make something as an internal within the assembly, the other classes can access it. But outside this assembly, if you have one more assembly over here, And within this assembly, if there is a class that cannot access this one, that is the meaning of saying internal. This is internal to the assembly. You are already familiar with the protected. Protected means it will be available only to the derived classes. So one class inherits from the other, the protected will be available to the other side. You have protected and internals together. Remember, protected means to say that even the classes which are outside the assembly will be able to access it. What is protected internal means to say that it is protected. That means to say that the inherited classes will be able to access the value, as well as it is internal. That means the classes which have nothing to do with the base class, but in the same assembly will be able to access it. So in other words, to say that, let's assume that you have a class here, assembly here, and you have a class that is inheriting from the other class. So if it is a protected, it will be available here, but it will not be available to any class which is outside this and which is not inheriting. But if you make protected internal, means even though there is no inheritance, because it is internal, the other classes within the same assembly will be able to access it, even if they are not inheriting it. So that means to say that it is shared among the classes within the same assembly, as well as those who are deriving from it. The derived classes could be elsewhere. So I can have one class which is trying to derive from this class. So when the protected will be available anywhere, as long as it's being visible to the other side. So that means to say that the other class, that the derived class could be there in the other assembly altogether. Let's look at the example over here. You notice that here there is a member, monthly profit, and there is a method. Both of them are private. That means to say that these two methods as well as the field will not be available outside the class. If you make something as a public, that means to say that this will be available to the entire world, but the monthly profit field is not available to the world. It is a private to that particular field. So let's look at the difference between an internal and public file. So when you say internal, you notice that if these two classes, if you say that they are internal, that means to say that they can communicate with each other. They can do anything within this, isn't that this is an assembly? So they can do anything within this assembly, but the outside world can't access them because they are not available for the outsider. But if you make the class as a public, it just means to say that anybody from the outside world, so isn't that these are all the assemblies which are there, will be able to access something within this assembly. So anybody can come and access it because it is publicly available, not only within this class, not only within this assembly, outside this assembly. Anybody can access this publicly visible to everyone. So let's look at the default. Whenever you create a class, for example, you notice the class that is created over here does not carry a public, private or anything. If you directly create a class without specifying the access specifier, it needs to say that it is internal. By default, the classes have the accessibility internal. So they will be available only within that assembly. Whereas the members could be the field, the methods, the events, the static value or anything, all of them are assumed to be private. That means if you create a method here without specifying the access specifier, that method will be assumed to be private and it will not be available outside the class. So again, if you create a field without specifying anything, it's assumed to be private. So that means to say that's the. Let's look at a simple example of creating a class. So I assume that you have a class that is getting inherited from the one more class. Now, whether it's a class or whether it is a interface in C#, it is very difficult to figure out whether it's a class or whether it's an interface. And you have also faced the same problem in C++ because there is no special keyword like inherits or implements. These two keywords which are there in Java, they are not available here. We are using only colon to say that it gets inherited. Now, if you notice over here, this is a enumeration that is being created. Whenever you create an enumeration, they are publicly visible directly. So you notice this particular enumeration is publicly visible. So directly you can access it. And in fact, they are assumed to be static. So when you try to create enumeration, it's assumed that you want to go make them as a part of the class itself rather than the object, because they doesn't make any difference. You create an enumeration when you want to create a constant key for a given value. So let's look at the declaration now. You have a private make, private vehicle ID, and private location. Then this is the constructor for the class, and the constructor, you know very well, has the same name, but there is nothing that says it is a method or anything. And this is a parameterized constructor that takes 3 values, and you have the constructor, and you have the public method that is used to create something. Okay. How do you create an object out of this one? So you just say that car c equal to new car, and you call this constructor and give the value. And if you notice over here, what I'm trying to do now is I'm saying the car, which is this one. Then I'm saying make, which is a enumeration, and then I say BMW. So I get the enumerated values for the class, and I'm not calling it from the object, I'm calling it from the class itself. That means it must be static, so it is directly available within that. Then you specify some values and some location, and then call the method. Now what are fields? You are already familiar. Fields are the one that holds the values. They are the member variables. Okay. They can hold the structure, class, or array. You can create any type of field. And the way in which you create the field, you are already familiar. You specify the data type and the name of the field. Again, you can have the default value being set to them, like for numeric, you have 0, any type of numeric. Boolean will be false. Default character will be ASCII 0. That is the this is the ASCII value. Do not get confused with the null that you are using. That's the system.null, and the null reference and null kind of thing. This is the ASCII null. It is not the null that you are familiar with. The enumeration, it is 0 first value, and the reference will have the null. This is system.null. Null means nothing. Here for character, null means the first ASCII character, which is a control character, and which is also called as null. As usual, whenever you create a variable, so you don't have to go with the default values like this. You can assign a direct value to this. For example, if you are creating a variable int seconds, you can directly specify the value that I don't want to, because you know that int default value of int is 0. You can say that I don't want the default to be 0. I want the default to be 30. You can specify any value. For the next one is the static field. By now you are familiar. Statics are those fields which are part of the class and they are not part of the object. Static means it's a part of the class and they have nothing to do with the object. So static, anything that is mentioned as static, you will not be able to access it with the object references. So here we have a class called as static, and you are assigning some value to this one. So static sales tax equal to 20. How do I access it? You don't have to create any variable for this. It's the name of the class followed by the name of the data type. Immediately you will be able to access it. So this is how it will go. They are not constant. They are just a variable, but they are the variables that are part of the class. That means they are common for any objects that you are going to derive. You don't have to have an object to access them. Once you have the class, they will be visible. So the next one is the constant. Now constants are used when we want to store a constant value. One important thing to be noted is constants are evaluated at compile time. That means the compiler must be able to get the values of the constant. If the compiler is not able to get the value, then the compiler will raise an error saying that I can't get this value and I will not be able to set it as a constant. What does that mean? All the objects that you create, the student, the employee, and all these objects that you create, The objects gets created at runtime. You are saying new student, new employee, new manager, new car, all this new that you are using. When you run the program at runtime, those objects get created. And this one is evaluating it at the compile time, not at runtime. That means to say that you cannot create a constant for the car, the bike, and all these things. Any objects that reference that you are going to do it, you can't have a constant for them because compiler will not be able to get its reference. So any reference to an object can't be constant. The values can be there. For example, you have constant string version equal to 1. This is all right. Remember, string is a class and this is an object, but the string is a special case. You know very well, every programming language, string is a special case. They are treated like a basic data type, but in turn, it's a object by itself. Here, a thing will not be possible. Now, again, one more, you notice a string S1 is equal to ABC plus DEF. The compiler is able to guess that the ultimate result of this will be A, B, C, D, E, F. The compiler gets it. Compiler is able to make a simple calculation saying that 1 plus 2 is 3 and it can assign that value to it. Compiler can call, remember pi is a constant which is a static constant declared in the math class. It's a constant. Its value is a constant. So compiler is able to get that, multiply it with the i3 which was declared previously and then assign this value. It's all possible. But when you try to call a direct method like this, sign of something, the compiler fails altogether because the sign is not a static method. Even though sign is a static method, it has to evaluate that particular sign, it has to call that sign, get the value of it and then set it back to the value. So the compiler says, I will not be doing it. This has to be executed and then only I can do it. So similarly, if you try to do this one, suppose say, let's say, isn't that this is not there, and let's say this is instead of a constant, you have this data type is student. Student S, if you try to do, is equal to new student. This is going to miserably fail because the compiler will say that I will not be able to create an object at the compile time. You have to run it and then do it. The same thing if you try to do a calculation that requires calling a function and other things, then everything fails miserably, so it is not possible. What if you really want to do that? If you want to create a constant, a read-only value, you can just, what's the meaning of saying constant? Its value can't be changed. It's very obvious. And by the way, how do I make something as a constant is you use the keyword const to make it as a constant. So all of them are constant. Now their values can't be changed. You are already familiar. It's not something new. What if you want to have a evaluated value but still a constant? In that case, go for a read-only. So read-only will be initialized at runtime. But once it is initialized, it remains same. It remains constant. So whereas a constant is initialized at compile time, so you don't have that flexibility. Read-only is like a constant, but read-only is initialized at the runtime. So you have a option of setting it. Suppose if you want one student to be a constant value or one employee as a constant, do not want others to make changes to it, but one constant. You can't directly do it with the const, that is the constant. Instead of that, you just go for read only. So when you make something as read only, it gets initialized when the constructor is gone. So in the constructor, you can initialize it. So here you notice that read only string 1 is there. Values are not given during the declaration, but in the constructor, the value is given. Remember, only at the constructor you can give the value. Once the object gets created, it's all gone. Then onwards, you will not be able to assign any new value to it. So you can directly assign a value at the declaration. This is allowed, and as well as there is a flexibility in the constructor. You can assign a value to the read-only members. So this is something that you can use if at all you want to use the constant. So let's look at an example over here. So we have public int x, which is not a read-only, not a constant. Public read-only int y equal to 25, that means directly initialized. Public read-only z, and the z gets initialized to 24 at the constructor. Again, because it's a constructor, you notice that I can get the value from the outside world. I can ask the outside world to supply the value and then take this value, add it to the z, and you notice that z is a read only. That means I can ask the value from the user and then get that as a constant. For example, I can, when I create a class or a course, I can ask how many students are there. Once they say that this course has a 25 students, the 25 will be a constant. So I can say how many members are there, how many cars are there. I can ask what is the total number of elements. Let's say 50, I can take 50 as a constant, then I can do the calculation. Remember, when I say constant, I can't use const for that. I have to make it as a read only. So I can say 50 is the number of students, or 25 students are there in the course. That means those numbers will not be changing. If you want to retain that as a read only value, you can anytime do that thing. So here you notice the same example being called, and we have the value 11, 21, 32, and these are supplied to 11, 12, or 22 and 33, whatever value which was 32. So these values will be directly assigned, and it is possible to assign. Remember, y had already 25 here, but y is still given a value. It is all allowed. Up to constructor, you can make the changes. But once the constructor runs, it's all over. For example, if you notice over here, the constructor is called. Then you set x equal to 55. This is allowed. The reason why x equal to 55 is x is just an ordinary field. Its value can be anytime we set. There is no problem with it. But you notice over here, you are trying to set y equal to 66 after the constructor is called. Somewhere else you try to set it. It's not allowed. The reason is y is read only. Its value can be set only in the constructor. But once the constructor is over, its value can't be changed. It just becomes a read only. Now let's look at the other type, and that is the properties. Now the properties, as told before, is nothing but it's a flexible way of using a field. So most of the time we use a field, but we want, you know very well, whenever you say the object-oriented concept, one of the main property of the object is encapsulation. You want to encapsulate it. You don't want the outside world to know what is happening within the object or within the class, but you want the outside world to interact with it. So you give some hooks to the outside world so that they can fit into and supply some value and take some thing out of your class. How do we do that thing? The way in which we do it is we set the properties. Now the properties have the behavior of that of a method. That means you can assign the value, you can give the value and take the value back, but they behave like a field. So their syntax is like a field, but in turn they are a method. So these methods are the specific method, the getter and setters. You know very well, getter is used to get the value, setter is used to supply the value to the other side. Again, because it's a method, what you get from the outside world can be validated to check whether the things are proper. Then you can assign it to the field. So let's look at a simple example over here. This is the general structure of the properties. You specify the access modifier. I think the font went down. The return type and the property name. That's the dot. I think the font misplaced. So you specify the access specifier like public, private, and other things. What is the return type? Int, float, or anything. Name of the property, and you have the getter and the setter, both within the same parenthesis. So let's look at a simple example. We have a field, private string and my string, and then I use this one. So this is the access specifier. It's public. Remember, the field is private but the access specifier is public. You can make it as a private also, but it will not be available to the outside one. Then you will have to rethink why you are doing it. Then you specify the type. So this is of type string, and then you specify the name of it. So like public string, my string. So this will be available to the outside world. You notice that C sharp is case sensitive. That means these two variables are not the same. They are different variable altogether. Then you specify the get and set. Get is used to return the value. If you notice over here, the get returns the value of my string. So it returns this one. The set is used to set the value to the my string. Value is a keyword. This is the one that is used to get the value from the outside world. So this behaves like a method. The difference between this and the method that you are using is the set method will take only one value as its parameter. It will not take more than one value as its parameter. So how do I access it? Now let's assume that this is within a student class. So let me assume that this whole thing is within the student class. And if I want to access it, I'm going to say student std equal to new student. I do that thing, and then I can say std dot my string. Remember, my string that I'm typing here is this one, capital M, not the field name. And if I assign a value equal to 50, what is it going to do? This 50 will be given to this value, and this value is given to my string, and it will be stored in the field my string. Now, if I do this one, say write line std dot my string. In this case, what it is going to do? Now, remember, I'm not assigning it. I'm calling it back. So this is going to call the get method, which is going to return the value which is stored in the my string, and it's going to return it back to me. So it is going to behave. If you notice here, it behaves like a field. Okay, it behaves like a field in both the case, but in turn, there is a method associated with it. So this is how it goes, and the value is a keyword that indicates the one. Again, it doesn't mean that you have to have a getter and setter. You can have only getter and only setter. Again, for the getter and setter, you can specify the access specifier. You can say, in this case, if you notice, you are saying private set. That means to say that only within the class, this value can be set. Public can't set the value. So you can specify even that. So a simple one more example, within the entire thing, you have my class, and you specify a private int, which is a field name. Then you call a property x, get the value, will get the value from here. Remember, these two names need not be same. They may be relevant or irrelevant or anything. They may have something in common. They need not have something in common. This is the name that will be available to the outside world. So this one will be available to the outside world. This name will not be available. The reason is it is private. So when you if you create an object of my class and then put a dot, what x that is available out is the capital X, not the small case x. So get will return the value. Remember, it need not be x itself. It could be y. It could be anything. You can do some calculation here before returning it. You can do some calculation and then return the value. Same thing, before setting it, you can do some calculation on the value and then set the values. So you can do anything with it. Here is an example that actually shows that thing. So we have the width and height. So you have int width. So this is small case and it is capital. It will return the value over here. But when you try to set it, you are first verifying whether the value is greater than 0. If the width is greater than 0, we set the value, else we throw an exception saying that it is not enough. So before you set it, you can do that thing. Same thing, when you return the value of height, you can do it, but when you set it, you can do that thing. The reason why we use this kind of thing is you may ask the user to give the values in kilometers, but you store it in inside your program or inside your class. You may store it in meters, or you can ask it give me in hours. Then internally you may store it in seconds. These are all valid. So what you show to the world need not be the one that you are actually storing. So you may ask it give me in kilometers, but then you convert it into feet and other values and store it. So this is the reason why we use the properties. There is one good thing about the properties from C# 3.0 version. Instead of writing this whole thing, entire thing, you can simply create a property by directly specifying it. So you say public decimal current get and set. So this is one line equivalent of the whole thing that you have written over here. At any time you can expand it and do it. And this is the usual thing that we use. So it just means